All right, as promised, here is our last example on our review homework or review notes. So you should try this question out on your own and then compare it to what I get. So when I do have a question like this where it's giving me a lot of information about the derivative or the second derivative of our function f, I do like to write out what each of these things mean for our original function. So the first derivative being positive means that our function is increasing. The second derivative being negative means that it's concave down. So our graph is going to look something like that. And drawing these shapes also kind of helps me be able to translate this to the actual graph when I go to graph it. So on our interval from -3 to 0, we're still increasing, but now we're concave up. So our graph is going to look something like that. We're still increasing from 0 to 2, but now we're concave down again. Sorry, handwriting is so bad today. And so our graph is going to look back like that. And then from 2 to infinity, we're decreasing finally, and we're concave down. So our graph is going to look something like that. All right, so we've got those, four pieces of our function there. Then we're told that the first derivative at -3 is 0, and the first derivative at 2 is 0. So that means we've got to have, that min or that max or that place where we level off. So that's how our function is going to have to look at those places. And then our second derivative being negative, or second derivative being 0 at -3 and at 0, these are possible points of inflection. And so let's take a look at what we've got here. So yes, at -3, we change concavity. At 0, we also change concavity. So we do have points of inflection at those two things. Now, in terms of the mins and maxes that we've got right here, at -3, we are increasing before and increasing after. So this is not a min or a max. So our graph needs to do something like that at -3. So it's got to level off so we get that derivative of 0, but it's not going to be a min or a max. But at 2, we change from increasing to decreasing, so it's going to look like that. We're going to have some sort of maximum there. Okay, so now let's put all of the pieces together and draw an actual graph. So again, sort of what the y values are, that's not going to really matter, but I'm going to mark some points on here, and I'm just marking a point to start that I want to be increasing in concave up until we get to -3. Then after that, we want to be increasing, or concave down, excuse me. And then after that, we want to be increasing in concave up, but maybe I want to redraw that because we do have to do that sort of flattening out bit at -3. So I'm going to draw it so it's a little bit more distinctive. So we've got to be concave up until we get to 0. Okay, let's keep this concave up. Maybe we'll, and this is what I have to do. Sometimes I have to draw it again. So keeping concave up until we get to 0. Oops, we gotta, maybe we'll try to get there. Staying concave up, and then we can go to concave down there. Whew. All right, it's a little hard to do that sometimes. So sometimes I have to erase and draw again. And then at 2, we're going to have a maximum, and we're also going to change to, well, we're staying concave down, so we're not changing concavity. So it's going to look kind of something like that. So yours might look slightly different. It might be a little bit more exaggerated, but these points where you change concavity, they're good to mark, as well as any points where you have mins or maxes.